Hi everyone, my name is Maryam Karimi and I'm going to present contextual decision making and action enforcing applications in IoT using SDN. Some applications use historical data to detect a situation or decide on an action. These applications require context and they need an architecture to provide this context to them. SDN is one of those architectures. The controller in SDN has a global view of the network. It receives all the packets from the switch and decides what action should be performed for those packets. SDN provides global view of the network, however, it lacks security. So we integrate it with SCP to provide security. In SCP, the controller is safe and secure behind the SCP gateway, and only SPA packets which are for authentication, authorization, and requesting services that are going to be forwarded to the controller. We use this architecture in a framework in which user is sending the data to the STP SDN gateway. It will forward it to the controller. It will add some context information to the request and forward it to the application. The application decides what to do with this packet or request and forward back the reply to the owner gateway. The owner gateway then decides how to store this data. So we provide three scenarios to see if this architecture actually works. In the first one, the patient is sending a video to the doctor and he wants to make sure that the quality of service of this video is maintained by using historical data that and build a model that limit the access point rates, the other access point rates, and control the delays and traffic. It showed that it reduced the delay and packet loss. In the second scenario, the patient wants to store all the data in a server, and later on, the doctor wants to retry the data to make a diagnosis. And we want to make sure that the integrity of the data in the server is maintained. So we provide multiple levels of data integrity. As the security increases, the combination storage and time complexity also increases. And we choose multiple parameters such as data merit, lifetime, affordability, latency, and other things to choose one of these integrity verifications. It shows that comparing to other methods, it reduced time and storage. In the third scenario, the patient is sending information to the server and wants to make sure that the data is always available. So for this one, we use multiple hash functions to summarize the data, add an erasure code, and use a Bayesian regression model to choose what is the tolerable error rate and to choose other parameters based on that. So it reduced the storage. So based on these three scenarios, we actually proved that this architecture is working for IoT networks. Thank you so much. And here's my email if you have any questions.